Hello, welcome to another edition of TutorTube, where the learning center's lead tutors help you understand challenging core concepts with easy to understand videos. My name is Amit, lead tutor for biomedical engineering and mathematics courses. Today we'll explore cross product of vectors. Vector. A vector is a physical quantity with both magnitude and directions. We can take force as an example of the vectors, and we need both magnitude and direction to define force. Here on example we have force vector here with some magnitude, and it is an angle theta north of east, and that theta tells us the direction of the force vector. The cross product of two vectors. The cross product of two vectors is a vector multiplication of two vectors. Here on the right hand side we can see the vectors a and vector b, and vector a cross b is the vector multiplication of the a cross b vectors, whose magnitude is equal to the area of the parallelogram formed by two vectors, and the direction of the a cross b vector is perpendicular to the plane containing both a vector and b vectors. Here a cross b is perpendicular to both a vector and b vector respectively. We use screw and right and thumb rule to find the direction of the cross product. Now let's try to find the direction of the cross product. As we discussed, here we're going to use the right and thumb rule. Now in the figure on the top here, if C represents our cross product between A and B vector, that is A cross B, then we put four fingers towards the A vector and we rotate them towards B vector, and our thumb will give the direction of the cross product, which in this case is pointing upward. On the next figure here, we want to find the direction of the B cross A, that is B cross A. So in this case we put four fingers towards the direction of B vector and we rotate towards A vector, and this negative C vector will give the direction of B cross A vector. We can see that A cross B and B cross A vector are not same since their directions are opposite, and that's why the cross product always gives a vector quantity. Talking about the representation of vectors, vectors are usually represented as shown here. They are usually represented by arrowhead on the top of the capital letters or the bold capital letters. Here a vector is represented as a1i plus a2j plus a3k, and b vector is represented as b1i plus b2j plus b3k. I, j and k are just the unit vectors along the x-axis, y-axis and j-axis respectively, so they represent your x component, y component and z component respectively. In some of the mathematics courses you can also find vector being represented with this notation that's given right here. Finding cross product of vectors. Let's assume that our a vector is a1i plus a2j plus a3k and b vector is b1i plus b2j plus b3k. So mathematically we can find the direction of we can find the cross product of the vectors by setting them in the form of 3 by 3 matrix. So to set them in the form of the 3 by 3 matrix, we draw kind of like the two horizontal lines, and we write the individual individual unit vectors, so I, j and k, and below the unit vectors we write the coefficient a1, a2, a3, b1, b2, b3. So for the a vector it was a1, a2, a3, for the b vector it was b1, b2 and b3, and we also give the sign notation on top of them. So for I, positive, negative, positive, so it's alternate, positive, negative, positive. So this method, what we are doing here is actually the calculation of determinant of the matrix, 3 by 3 matrix, and if you don't know what's that, then let's not worry too much about that right now. So to calculate the determinant of 3 by 3 matrix, we do write the sign notation and then we write the unit vector first. So we write positive I, so that's on the first column, so positive I. Now to get what's inside here, we cover I. So you can do this using your finger if you are writing on a paper. So we cover I, right? And we write everything that's left here. So we have A2, A3, B2, B3. That's what we have right here. Now to find for the J, similarly, since we have negative sign here, we write the negative J. And to find what's inside here, instead of covering for I, now we cover J. Once we cover J, we're gonna write everything that's in there. So I have A1, A3, and B1, B3. So I write A1, A3, B1, B3. Similarly, to find for the K, it's a positive K. So I write positive K outside, and to find what's inside of this thing, we just cover the K, and then we write A1, A2, and B1, B2. Just remember to set up your vectors like this, and then write like this. So on paper you can just cover A, K, you can just cover the K, and you can write A1, A2, and B1, B2. So now this is your 2 by 2 matrix, and again you have to use your determinant rule for the 2 by 2 matrix. If you don't know what's that again, let's not worry about that. Let's just follow here. So to find the determinant of the 2 by 2 matrix, we write what's outside, right? Now to find the determinant of the 2 by 2 matrix, we multiply like this, and we subtract by multiplying like this. So I'm gonna have A2 B3 minus B2 A3. Similarly for here, I have negative J outside, so to find the determinant inside this one, I want A1 B3 minus B1 A3. So A1 B3 minus B1 A3. Similarly, on this case, we have positive K, A1 B2 minus B1 A2, and that's what we have it right here. So that's your cross product of vectors, and here I, J, and K, again these represent the X component, Y component, and G component of your vector, and we can say that the cross product actually gives the vector quantity. Now let's try some of examples. So here we take an A vector, and we the A vector is 2i plus j minus k, and B vector is negative 3i plus 4j plus k. So like we said before, we set up our like this, and we have here positive on the top, here negative, and here positive. Now to find the A cross B vectors, we have to take the determinant of this 3 by 3 matrix, and to take the determinant 3 by 3 matrix, we write positive I, that's right here, and we cover the I. Now we have left 1, 4, negative 1, and 1. Now to find for J, we can write negative J, and we cover J. So if we cover J, 2, negative 1, negative 3, and 1. So that's what we have it right here. Similarly, on your paper, or you can cover the K, and then you have the positive K, so you have positive K here, so 2, negative 3, and 1, and 4. Now the next step is to actually finding the determinant of 2 by 2 matrix, that we have it right here. So to find the 2 by 2 matrix, we have positive I, that's right here, positive I, so we cross multiply like this, so 1 times 1, and subtract like this, so 4 times negative 1. So we have 1 times 1 minus 4 times negative 1. Similarly, you take negative J, that's negative J here. Now to find what's inside here, the determinant, we do 2 times 1 minus negative 3 minus negative 1. Similarly, in this case, we have positive K, and we have 2 times 4 minus negative 3 times 1. So if you simplify this enough, you get 5i plus j plus 11k, and that's the final cross product of A times B. Cross product of A times B, yeah, A cross B vector. let's talk about the magnitude of the cross product. So finding the magnitude of the cross product is same as finding the magnitude of any vectors. So we represent magnitude with the modular sign. Uh, so and it is calculated using the square root of x component square plus y component square and then g component square. So if we look on the previous case here, we found that a cross b vector was 5i plus j plus 11k. So our magnitude of the cross product is just 5 square plus 1 square plus 11 square and whole square root. If you type that in calculator, you'll get 7 root 3. Similarly, for vector a, that is 2i plus j minus k, and b vector, we're going to use the same method. We're going to have the x component square plus y component square plus z component square and take the square root for the whole thing to get the magnitude of the a vector and magnitude of the b vector. So the whole process of doing this is very useful to calculate the angle between the a and b vector using a cross product. So if we know the cross product and if we know the two vectors, then we can calculate the angle between these two vectors. And how do we do that? We have the formula that magnitude of the a cross b vector equals to magnitude of a vector, magnitude of b vector times sine of theta, and this is just represents the perpendicular, that's that direction. So you don't have to worry about this while you are calculating the magnitude, while you're calculating the angles or while you are solving mathematically. So when we divide both sides by a magnitude of a vector and magnitude of b vector, we get theta equals to sine inverse of a cross b vector, and it's actually a modulus here. So we are actually dividing magnitude, not the vector, but we are dividing the magnitude of the vector cross product. And then a vector times b vector, this will equals to sine inverse. We have for the magnitude of a cross b vector, we have 7 root 3. That's what I have it here. And for the magnitude of a vector and b vector, we have magnitude of a vector 6 and magnitude of b vector 826. When you plug these in the calculator, you should get 75.9 degree, and that's the angle between a vector and b vector. Now let's try another example. Here we have a vector 3i, 2j and 1k, and b vector 2i plus j plus k. Again, we set up vectors like we discussed earlier. So we set a vector like in a 3 by 3 matrix, like calculating a determinant, and we have positive, negative and positive. So to calculate for I cover the I. Now I have 2 1 1 1. Now to calculate for j, I cover j, and since it's a negative in front of the j, I have negative j right here, and I cover the j. So I have 3 1 2 1. Similarly for k, you can cover the k and you can get 3 2 2 1. Now the next case is just calculating the determinant of the 2 by 2. So this I write the same thing, positive I. Now here to calculate for this one, I have 2 times 1 multiply like this minus 1 times 1. So 2 times 1 minus 1 times 1 minus j. So I have 3 times 1 minus 2 times 1. So just the 3 times 1 minus 2 times 1 plus k, and I have 3 times 1 minus 2 times 2. When you solve this or when you plug it in calculator, it's a simple algebra. So you get 1i plus minus 1j minus 1k. So our final answer for the cross product of these two vectors is 1i minus 1j minus 1k. Now to find the angle between the two vectors a and b using the cross product, we find the magnitude of the cross product again using the square root and then squaring its component. So 1 square plus negative 1 square minus negative 1 square, you get root 3. And for a vector, we do the same thing. So x component square plus y component square plus g component square, and x component square, y component square, and g component square. So we get 14 root square root of 14 square root of 6. And if the theta is our angle between the two vectors, then we, using the formula that we found earlier, our theta would be sine inverse of, again this would be modulus of a vector cross b vector over the magnitude of a vector times b vector. So we found the magnitude of a cross b at root 3, magnitude of A vector is 14 and magnitude of B vector is 6. When you plug these in calculator, you should get answer 10.89 degree. Now going to the next slide, here we have summary. So let's summarize what we discussed in this video today. We discussed the vector has both magnitude and direction, while scalar quantity only has the magnitude, and that's the big difference between these two. The force is an example of the vector quantity. Cross product of two vectors always gives a vector quantity, and right and thumb rule is used to determine the direction of cross product of two vectors. The magnitude of the cross product of two vectors is equal to the area of the parallelogram created by two vectors, and we can also calculate the magnitude of the cross product is magnitude of A vector, magnitude of B vector, the magnitude of the A cross B is magnitude of A vector, magnitude of B vector multiplied by sine theta. And here are the references. Thank you for watching TutorTube. I hope you enjoyed this video. Please subscribe to our channel for more exciting videos. Check out the links in the description below for more information about the Learning Center, and follow us on social media as well. See you next time.